Okay, we're going to be doing acid and base chemistry. Sorry. We are going to need to know properties, definitions. We're going to have to deal with indicators, pH scale, concentration versus strength, what's the difference, and neutralization, how to neutralize solutions, which is called neutralization. These are the topics that we will be discovering in the next 3 weeks through labs and tests at the end, and we are calculating pKa, pOHs. There's a lot of math, so hopefully you're ready to use your logarithm skills from math into chemistry. I understand some of you guys might not have gotten to it, but I hear that you're currently about to, like, actually tomorrow. Okay, properties of acid and bases. Just acids contain H plus ions. It has a pH less than 7. For your homework, you need to write these down. It tastes a bit sour. Think of it like a sour warhead. It will hurt. It feels hurtful, like it will hurt right away. And it turns the litmus paper red because the lower the pH, it will turn red. It reacts with bases to produce hydrogen gases. And when it produces the hydrogen gas, it will also produce salts. Think of salts. Also, acids are used to make electrolytes. Bases contains OH. pH greater than 7. It's bitter to the taste. The thing with bases, which makes bases so dangerous, is when you get it on you, you won't feel it hurting until it's already seeped through the skin. It actually won't hurt until it's too late and you won't be able to wash it off. And it's really slippery. Like you can just glide your hand across. It turns the litmus paper blue. Does not react with metals. It reacts with acids to form salts and water. And it also is used in electrolytes. Okay, pH of some common substances. HCl has 1 molar. Gastric juice has about 1.6 pH. Lemon juice is about 2.2. Vinegar is 2.8. Soda is about a 3. Orange that you eat is like a 3.5. Apple juice is a 3.8. Tomatoes 4.2. Coffee is 5, so it's very acidic. It will wear off your teeth. So if you're a coffee drinker, remember, or a soda drinker, remember what happens to your teeth. I'm guilty with soda. Soil is typically 5.5. Bread is 5.5. Urine is about 6. Milk is 6.4. Water, distilled water, pure water is 7. Drinking water is 7.2. Remember how I said distilled and pure water? Drinking water is actually a 7.2. Your blood is about a 7.4. And so on to NaOH, which is a pH of 14. Right here, the H plus ions of the acids is equal to the OH ions of the base. This side's basic, this side's acidic. And I got carried away with the pictures. Okay, definitions of acid and bases. You need to write these definitions down so you have them in your notes. Aromatic acid is when it releases H plus into water. The base releases OH negative into water solution. A Bronsted-Lowry base is, you're talking donors and acceptors. Acids donate, bases accepts. A proton is really just a hydrogen atom that has lost an electron. That makes it positive. Remember, it's just a positive. Lewis acid and Lewis bases are electron pair acceptor is the acid. So these are opposite. Here the acid donates, here the acid takes in. Base, again it's opposite. So these two have an inverse relation in your mind. Think about it. Okay, indicator, litmus paper. Red equals acid, blue equals base. There is litmus paper that you can get the exact pH. Acids. Oops. It will change phenolphthalein to clear. The way we get it into pink is we add bases till the pH is above 7, and that's when it will turn pink. And that's what it looks like. When you dump a bunch of base into an acidic solution, it becomes like that. pH scale. As you can see, when you're doing pHs, you're actually in reality doing 10 to the 0, which is a 0 pH, up until 10 to the negative 14. In fact, I actually just read an article. Is it possible to get a negative pH?
Probably.
Mathematically, yes. In practice, no. It's actually quite an interesting article. If you want it, I can get it for you. But you see how it goes negative, goes all the way up to negative 14? That would be a pH of 14. Just some things. Also, this is a scale of common household appliances. We use this scale to measure the strength of an acid or base. How far away from 7? If it's at 0, it's a strong acid. If it's at 6.5, it's a weak acid. If it's at 7.5, it's a weak base. If it's a 14, it's a strong base. So it's off of that 7 part, not from each side. It's from the middle outwards. How you calculate pH is pH equals negative log of the concentration of H plus ions. pH stands for power of hydrogen. That's why we have this. Go ahead and write these two things down. This will be number 3 on your list. A pH of 8 is a pH of 8 is basic, is more basic than a pH of 7. A pH of 4 is more acidic than a pH of 7. And it contains more or less hydroxide ions. This will have less more hydroxide ions than 7. 8 will have more. Remember, it's the negative power. A pH of 12 is more basic than a pH of 4. Dissociation. When we have solutions, you are actually thinking about how the ions are dissociated. When ionic compounds dissolve in water to produce ions in a solution, the ions, remember how you don't just have H2O, you actually have H plus OH negative all around that solution. So you have to start thinking in this ionic mindset. Ionization is when molecular compounds dissolve in water to produce ions. We are making ions. We have ions everywhere. Strong acids and bases. Ionize and dissociates essentially 100% water. Therefore, the reaction goes to completion. And no equilibrium is established.